Uh, welcome to CXC Math TV. Um, Yesterday was the CAPE Unit 2 paper. Just want to run through this paper. Haven't really looked at it extensively, so I want to see what the paper was like, to go through it, right, and see, was it a difficulty here? Just from skimming through it, I thought it looked pretty easy. I thought this was the easiest paper I've seen in a long while. So let's go through this paper and see if that was the case. I thought it was a pretty easy paper, just on skimming through. But it started with this. Given that 3y squared minus 4xy plus sine xy is equal to 5, determine dy dx. All right, I guess this can be seen as quite tricky. What I don't like something about this question right here. They should have put a bracket right here. All right, they should have put a bracket right there. All right, because here, just to put a bracket right here, that's all. All right, so differentiate both sides with respect to x. Differentiate 3y squared minus 4xy plus sine xy equal to 5. Differentiate the left side with respect to x. Differentiate the right side with respect to x. Differentiating 3y squared, carry down the power, subtract 1 from the power, multiply by dy dx. Minus, right here now we're going to use product rule. Using product rule, keep the first, multiplied by the derivative of the second, plus keep the second y times the derivative of the first, and the derivative of 4x is 4. Plus, when you differentiate sine, you get cosine xy, but then you also have to multiply by the derivative inside the bracket. And the derivative of what's? Differentiate cos xy. When you differentiate sine xy, you get cos xy, then you have to multiply by the derivative inside the bracket. But the derivative inside the bracket is actually product rule. So using product rule, keep the first times the derivative of the second, plus keep the second times the derivative of the first. This is equal to the derivative of 5 is 0. Now we need to make dy dx the subject. So we have 6y dy dx minus 4x dy dx. Plus and minus is now a minus 4y. And then we have a minus cosine xy being multiplied by x dy dx. I'm going to put the x at the front and then put dy dx right here. And then put a minus y at the front and then a cos xy right there equals 0. Now, looking at what has dy dx, this has dy dx, this has dy dx, this has dy dx. So we factor out dy dx, so we have dy dx in bracket 6y minus 4x minus x cosine xy, close up that bracket. Then what don't have dy dx, bring it to the next side for me, please. So bring it over, we have 4y plus y cos xy. And then now let's divide through what's under here. So divide by 6y minus 4x minus x cos xy, 6y minus 4x minus x cos xy. Cancel, cancel. So that's our expression for dy dx. So dy dx is equal to 4y plus y cos xy over 6y minus 4x minus x cos x. And so that is the expression for dy dx. How many marks is that? 6 marks. That's not bad. That's really not bad to start the exam. Differentiate cos inverse of 3x minus 2. All right. So remember, how do we differentiate cos inverse? So if y is equal to cos inverse of u, then dy over dx equal to minus 1 over the square root of 1 minus u squared multiplied by the derivative of u. So in this case, our dy dx is equal to minus 1 over the square root of 1 minus in bracket 3x minus 2 squared multiplied by the derivative of 3x minus 2, which is 3. So therefore, final answer dy over dx is equal to negative 3 over square root 1 minus 3x minus 2 all squared. So that's not bad. I think that's very, very easy for 3 marks. Easy peasy, we take it. Partial fraction in question 1, that's actually a surprise. Usually number 1 constitutes of differentiation and complex number. So I find it very strange that they put partial fractions in number 1. Usually integration is number 2, but that's fine. They tell you the denominator they should have. So we're going to say, okay, 2x plus 1 over 3x squared minus x minus 2 is equal to, looking at what they say it is, a over x minus 1 plus b over 3x plus 2. Now on the right side, add these two, LCM, x minus 1, 3x plus 2, x minus 1 into this denominator, that leaves 3x plus 2, 3x plus 2 into this, that leaves x minus 1. Over on this side, we have 2x plus 1 over 3x squared minus x minus 2. Then now we go ahead and equate numerators. So equate numerators. Equating numerators, we have 2x plus 1 equal to 3ax plus 2a plus bx minus b. Equating the x, then you have 2 is equal to 3a plus b. And by equating now the constants, we have 1 is equal to, that's 2a minus b. All right, so 3a and plus b, and yeah, that's it. So now we need to solve these two simultaneously. So what I'm going to do is I'm going to add the two equations. I put a plus, 2 plus 1 is 3, 3a plus 2a is 5a, b minus b cancel. So therefore, a is just going to be divided by 5, that's 3 over 5. Now, once we get a is 3 over 5, we can substitute now to find b. I'm going to sub in the second equation. So 1 is equal to 2 times 3 over 5 minus b. 1 is equal to 6 over 5 minus b. Bring over, b is equal to 6 over 5 minus 1. So b equal 1 over 5. Now that we find b and a, I'm going to zoom out for a second. Now that we find b and a, just to write the solution here. So the partial fraction 1 over 3x squared minus x minus 2 is equal to a over x minus 1, a which is 3 over 5, so 3 over 5 over x minus 1 plus b which is 1 over 5 over 3x plus 2. And then we can simplify this as put them together as one fraction. So it is 3 over 5 in bracket x minus 1 plus 1 over 5 in bracket 3x plus 2. I hope that's the answer. 3 over, yes. So right, that's 7 easy marks. We'll take that, right? 7 easy marks. We got what they asked for. Quite easy so far. Hence, they're going to ask you to integrate it. Hence, integrate. Let me try to write it out. Hence, integrate 3x squared minus x minus 2. Now we need to integrate this. Now, anytime they ask you the hence, you're just going to use what you did before. So instead of integrating 2x plus 1 over 3x squared minus x minus 2 dx, we're just going to integrate. We got it was this right here. So we're going to integrate 3 over 5 in bracket x minus 1 plus 1 over 5 in bracket 3x plus. This is what we're going to integrate. What I like to do is factor out the constants first. So I want to say this is equal to factor out the 3/5. 3/5 the integral minus 1 dx plus factor 1/5. 1/5 the integral of 1 over 3x plus 2 dx. Now, when you integrate 1 over x minus 1, that's log x minus 1. So 3 over 5 log x minus 1. 3 over 5 log x minus 1. Now, right here, you need a 3 in the numerator. So what I'm going to do, I'm going to times this by 3. And if you multiply it by 3, you're going to divide it back by 3. So 3 times, I'm going to put 15 right here. Right? So I don't want anybody feel confused. Basically, what I just did was instead of having 3 over 5, I rewrite, instead of having 1 over 5, instead of having 1 over 5, I rewrite 1 over 5 as 3 over 15. And 3 over 15 is the same as 1 over 15 times 3, but then I put the 3 in the numerator. That's what I did right there. So now this is plus 1 over 15 ln the denominator, which is 3x plus 2, and put the constant of integration k. That's an easy 4 marks as well. No jiffy so far. All right. Given that x equal 2t minus, it's a minus, 2t minus sine t, and y equal 1 minus cos t, determine d2y by dx squared. So they need the second derivative. So for the second derivative, first you have to find dy dx. All right. So first, before we find dy dx, let's find dx dt. When you differentiate 2t, you get 2. When you differentiate sine, you get cos t. And then when you differentiate cos, you get negative sine. But there's a negative here. So negative sign is positive sign. All right. And then we have to remember that dy over dx is equal to dy over dt over dx over dt. Cool. So now we need to find the second derivative, d2y by dx squared. Now there's a formula you're going to have to know. I think this is a very tricky question because many persons might just differentiate this and think they finish. You have to remember d2y by dx squared, it's equal to d by dx of, it's equal to d by dx of d by dt, I mean right here, sorry. To find the second derivative, it means you're differentiating dy by dx with respect to x, but because we have it in terms of t, it's actually equal to d by dt of dy by dx times, follow, times dt dx right here. So the dt's actually cancel if you can actually look at it. So instead of differentiating with respect to x, you're going to differentiate with respect to t, then multiply it by dt dx. Right here, we're going to say, oh, so therefore d2y by dx squared is equal to, use quotient rule, start with the bottom, multiplied by the derivative of the top, minus the top, times the derivative of the bottom. When you differentiate costs, you get minus sine. When you differentiate 2, you get 0. So that's 0 plus sine t over the bottom square, 2 minus cos t all squared, multiplied by dt dx. dt dx would be the flip of this, so that's 1 over 2 minus cos t. So our final answer is d2y by dx squared is equal to, we just need to simplify this. 2 cos t, cos times cos is minus cos squared t, sine times sine is minus sine squared t over 2 minus cos t all squared. And then if you want, you can simplify further, because if you factor out the minus, you have cos squared t plus sine squared t, which is 1. So you can write your final answer as 2 cos t minus 1 over 2 minus, this is a cube, square times 1 is cube, over 2 minus cos t all cube. Boom. Question 1 is finished. 25 marks. I'm sorry it's a little blurry. And this page was a little blurry. But so far the paper is easy. More integration again. Determine the integral of e to the 2x sine 3x. So now we're going to use the isolate rule. Isolate tell us that trig functions come before exponential. So this will be our u. So our u is equal to sine 3x, or du is equal to, when you differentiate sine, you get cos. Our dv is e to the 2x, so our v is equal to e to the 2x over 2. So now we can go ahead and integrate it. I like to call my integrals I, but you don't have to. So we have, I'm going to say let I equal the integral of e to the 2x sine 3x dx. I like to call my integrals I. So that means I is equal to uv minus the integral of v du. So I equal now u times v is e to the 2x over 2 times sine 3x minus v du. V times du now is the integral of, this is now e to the 2x cos 3x. I notice I have 3 over 2, but I'm going to factor out that 3 over 2. So now this is what I'm working with. So I notice I'm going to have to do by parts again. I'm going to have to do by parts again, and I'm going to call this j. So let j be equal to the integral of e to the 2x cos 3x dx. All right, and so my new u is cos 3x. My du is, when you differentiate cos, you get negative signs, a negative 3 sine 3x over, yeah, that's it. Don't need to say over 1. Please don't say over 1. All right, so that's what we have. U is cos, differentiate sine. dv equal e to the 2x, so v equal e to the 2x over 2. We use by parts again. So now j equal uv. So it's now e to the 2x cos 3x over 2, u times v, minus the integral of v du. So it's minus 3 over 2. I factored out the negative 3 over 2. But then negative and negative turn that into positive. Plus 3 over 2, the integral of v du, which is e to the 2x sine 3x dx. But this part right here is I. So j end up equal to e to the 2x cos 3x over 2 plus 3 over 2 times I. Remember the original question had in I. I'll zoom out so you can see it. So if I draw a line right here, me zoom out some more. I really want you to see the entire page. As you can see right here, I have to zoom a little more, or I can scroll. Yeah, this is better. So as I scroll up, you can clearly see this is what we have for J. But this equation needs to be substituted into this equation where we had I equal this. So finally, we're going to tell them. So I is equal to, that is, e to the 2x sine 3x over 2 minus 3 over 2 times j. But j is this down here. Do I have enough space? I hope I do. I'm going to put that right there, then say minus 3 over 2 times j. But j is all of this, so we got to put e to the 2x cos 3x 2 plus 3 over 2 times I. So this is what we have for I now. And remember, you're going to have to make I the subject. So if we simplify this, it's really I equal e to the 2x sine 3x over 2 minus, this is 3e to the 2x cos 3x over 2 times 2 is 4. Then 3 and 3 is 9, so that's minus 9. 2 times 2 is 4. I bring that to the other side. That becomes 1 is 4 over 4. So that becomes I plus 9 over 4I equal e to the 2x sine 3x over 2 minus 3e to the 2x cos 3x over 4. Then now 1 plus 9 over 4 is 13 over 4I equal e to the 2x sine 3x over 2 minus 3e to the 2x cos 3x over 4. Then divide through by, we need to divide through by what? 13 over 4. Dividing by 13 over 4 is multiplying by 4 over 13. The I equal, bring out the calculator. Multiplying by 4 over 13, half times 4 over 13. I haven't had my breakfast, so yeah, I have to use the calculator for these simple calculations. I haven't had my breakfast, and it's after 11. I've had some juice, but no breakfast. And then now the next one is 3 over 4 times the 4 over 13. 3 upon 13, so minus 3 upon 13 e to the 2x cos 3x plus some constant k. That's that. Sweet. Easy so far, right? We start a question to how many marks? 8 marks. We take it. Easy 8 marks. All right, it says use the Moivre's theorem to show that 1 plus 3i to the 4th power is equal to 28 minus 96i. It says use the Moivre, so don't expand it out. So using the Moivre's theorem, first we're going to have to convert this to polar form. So I'm going to call it let j equal 1 plus 3i. So therefore, the magnitude of j would be the square root of 1 squared plus 3 squared. 3 squared is 9 plus 1, that's root 10. That's root 10. That's the magnitude of j. Now we need to find the argument of j. So the argument of j is equal to tan inverse b over a. Tan inverse 3 over 1. I'll put that in our calculator. Tan inverse 3 1.25 radians. Can I get that in terms of pi? Maybe, maybe not, but this is what I get. So therefore, we can say that 1 plus 3i, therefore j can be written in the form r cos theta plus I sin theta. In other words, we're rewriting j in the form root 10 cos 1.25 plus I sine 1.25 radians. This is now J. All right, and then it's being raised to the fourth power. So now this is where the Moivre's theorem really apply. So therefore, we're going to tell them that 1 plus 3i to the fourth power is actually root 10 cos 1 point, well, let me put a bracket here, root 10 cos 1.25 plus I sine 1.25, and then we're raising all of this to the fourth power. So all of this is being raised to the fourth power. But of course, this is what? The Moivre's theorem. So using the Moivre's theorem, this is going to become, this is now equal to root 10 to the fourth power. And then the Moivre's theorem, so it becomes cos n theta. So here we're going to have now cos 4 times 1.25 radians. All right, so 4 times 1.25. I think it was 1.249, just to be specific. Now my head's turning left and right because I'm a big cricket fan and there's a lot of cricket being played. So trying to watch cricket and go through his paper at the same time. But I'm sorry about that. Cricket is so lovely. And then we multiply this by 4. So this is what we have, 4.996. So it's cos 4.996 plus I sine 4.996. That's what this work out to be. Then root 10 to the fourth power. The root, my gosh, cricket is so nice. I was watching this cricket game, but it's really lovely. Root 10 raised to the fourth power. And we're getting 100. This is equal to 100 times cos 4.996 plus I sine 4.996. And then now you multiply. So work out now cos 4.996. To see it here, guys. Remember our tan inverse 3 was this. It will multiply by 100. Boom. Why did I multiply it by 100? What are we supposed to get again? It says we're supposed to get 28 minus. Did I make a mistake somewhere? 3 square plus 1 square. That's 9 plus 1, 10. Tan inverse b over a. So tan inverse 3 over 1. I did that right. Tan inverse 3 is that. And then it is cos n theta. This was theta. We multiply theta by 4. We get 4.99 whatever. Then it becomes root 10 to the fourth power, which is 10 squared 100. Then we need cos of this. Okay. So we should have 100 times cos of the 4 point whatever. Okay, now we get the 28. I'm sorry, guys, because I'm so sidetracked with the cricket. Cricket is really entertaining. It's IPL for all those cricket fans. Then we need now plus. Now you're going to multiply the 100 times the sine 4.996. So now tan inverse 3 was this times 4. That was a 4.996. Now we need to multiply 100 times sine 4.996. I'll get the negative 96. So plus negative 96 times I, which is indeed 28 minus 96i. So it's proven, guys, that's very easy. So far, I think this is one of the easiest pure maths papers I've ever seen so far for Unit 2. Tell me what you think. I think it's very easy so far. All right. So that's what we have there. Now this one says derive a reduction formula. Can't get any easier than this as well. Hopefully it's 8 or 9 marks. 6. All right, no problem. So deriving the reduction formula, you have to break it up. So first thing you have to do is you have to break this up. So remember, sine to the nx can be broken up as sine to the n minus 1x, and then you multiply it by sine x. Right? So you have to break it up that way. So I'm going to call my integral I. So calling it I, which is the integral of sine to the n of x dx, is equal to the integral of sine to the n minus 1x times sine x dx. That way now we can use by parts. Now, how do you know which one to call u and which one du? Which one dv? I mean, u is going to be the one that you can differentiate in from any circumstance, and the one that you're going to call dv is the one that you can integrate. Now, looking at it, right? You can differentiate sine to the n minus 1x quite easily, and you can integrate sine x quite easily. So in this case, the integral of sine is negative cos x, and the integral of, well, the derivative of sine to the n minus 1x is carried on the power n minus 1, subtract 1 from the power n minus 2, and you multiply by the derivative of sine x, which is cos. So far, I is now equal to uv minus the integral of v du. U times v is going to be minus cos x times sine to the n minus 1 of x minus now the integral of v du. But because this is negative and it's going to be minus the integral of v du, but this negative and this negative make it positive the integral of cos times cos become cos squared. So now we have n minus 1 sine to the n minus 2x multiplied by cos square x dx. No problem. So now I equal minus cos x sine to the n minus 1x plus factor out the n minus 1. And then now we have to remember that cos square is the same as 1 minus sine square. So we end up have sine to the n minus 2x times 1 minus sine square x dx. So far I equal minus cos x sine to the n minus 1x plus n minus 1 times the integral of sine to the n minus 2x times 1 is sine to the n minus 2x, and then sine to the n minus 2x times sine squared. The bases are the same, you add the power, so that's minus, this becomes sine n minus 2 plus 2 is just n dx. That's what we have. So now we can separate it. So I equal minus cos x sine to the n minus 1x plus, you can break them up as two separate integrals, n minus 1, the integral of sine to the n minus 2 times x, and then this is now minus n minus 1 times I. Where did that I come from? Remember that sine to the n of x, we call this integral I. So bring over like terms now. So I plus n minus 1 I is equal to minus cos x sine to the n minus 1 x plus n minus 1 times the integral of sine to the n minus 2x dx. Now, I plus n minus 1I is just n times I equal to negative cos x. Whoa, Puran played a lovely shot. So, match is going well so far. Integral sine n minus 2x dx. Now divide through by n. So I is equal to minus 1 over n cos x sine n minus 1x plus n minus 1 over n integral sine n minus 2x dx. This is what I'm getting. Let me see if that's what they have. I certainly hope so. I certainly do hope so. Let me scroll up. Wonderful. That's what they have. Minus 1 over n cos x sine n minus 1 plus n minus 1 over n integral sine n minus 2. So we get it. We deal with it and we tell them, nice. And we deal with the question properly. All right, yeah. So we deal with the question. It's not so bad. Now right here it says, hence show that this integral is this answer right there. All right, so the first thing, I'm going to write out back the formula we had. So the formula we had was, I like to call it I. So remember, I was minus 1. Let's call it IN. Minus 1 over n cos x sine n minus 1x. Then we had plus n minus 1 over n integral sine to the n minus 2x dx. So this right here, realize it's to the 6th power, so we need I6. So sub in n as 6. So I6 is equal to minus 1 over 6 cos x sine to the 6 minus 1x plus 6 minus 1. 6 minus 1 is 5, I believe. And then over 6 times 6 minus 2 would be, 6 minus 2 would be what? I4. Now we need to find I4 and sub that in. So I'm going to do I4 in a different color. Let me do I4 in blue. So I4 would be equal to, put n in as 4 now, minus 1 over, you know what? I don't want to do it in so much lines. I don't want it to look confusing. So I6 is minus 1 over 6 cos x sine to the 5th x plus 5 over 6 times I4. And I4 now we put n as 4 is minus 1 over 4. Minus 1 over 4. Then it is sine to the 4 minus 1, which is 3. Put back our cos x. Then now we have plus 4 minus 1. 4 minus 1 is 3. 4 minus 1 is 3 over 4. And then we'll multiply it by I2. And I2 is the integral of sine square x dx. This is what we have. So in other words, I6 is equal to minus 1 over 6 cos x sine to the 5x. 5 minus 5 over 6 times 4 is 24. Sine cube x cos x. And then 5 times 3 is 15. 6 times 4 is 24 times the integral of sine square x dx. Is this what they have? Now 15 over 24 should be 5 over 8. I'm hoping, because then we'll finish. 15 over 24. Oh, yeah. It's 5 over 8. So we'll finish after this line. So this is now I6 equal to minus 1 over 6 cos x sine to the 5x minus 5 over 24 sine cubed x cos x plus 5 over 8 times the integral of sine square x dx. Proven. We did what they want. That's it. So far, module 1 was very easy, guys. Tell me what you think. I thought this was one of the easiest module 1s I've seen in a long time. Right? It's very fun so far. All right. So, I think that's a minus. Use 2 iterations of Newton-Raphson with initial estimate XO being 0.3 to calculate a new estimate for the root f of x equal 3x cubed minus 4x plus 1. So first thing, remember, xn plus 1 is equal to xn minus f of xn over f prime xn. So let's write the function right here. F of x, 3x cubed minus 4x plus 1. So f prime of x is going to be 9x squared minus 4, right? So if we want now, use two iterations, x0, we can plug it in now to get x1. So x1 is going to be x0 minus f of x0 over f prime x0, which is equal to x0, they said use 0.3 minus f of x0, which is 3 times 0.3 cube minus 4 times 0.3 plus 1 over its derivative, 9 times 0.3 square minus 4. Plug that in the calculator. Let me bring it out here. 0.3 minus fraction button. 3 times 0.3 cube minus 4 times 0.3 plus 1 over 9 times 0.3 square minus 4. I don't even know. Oh, 0.263. So I'm getting 0.263. So now we can go ahead and find our second approximation because they say use two iterations. So now x2 is going to be 0.263 minus f of 0.263, f prime 0.263, which is equal to 0.3 minus 3 times 0.263 cube minus 4 times 0.263 plus 1 over 9 in bracket 0.263 square minus 4. And we're going to punch that in the calculator. Just going to change it now. Change it to what we got for the answer. And sometimes I really don't know how to use calculator. Answer. 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 Man, that's crazy. And so using the second approximated rules, how many decimal places they wanted to? They didn't tell us, so we're going to use 0.301. So 0.301. That's what I got, right? And if you want, you can also check to see if that is somewhere around about correct. Put the calculator in equations. It's a cubic. A is 3. No x squared term. Minus 4 and plus 1. Solving it, 0.263 is the, and we got 0.301. Let me check that again because don't see why we should be so far off. 0.3 is not so close to 0.26. That's a long way off. I'm gonna put that back in again. Oh, okay, thank you. Right here. Guys, if you're in the exam and you make that mistake, please be careful. This was supposed to be 0.263. Don't give away your marks, right? So the correct answer is 0.263. Want to ensure that we get somewhere close to 0.263. So 0.263 minus fraction button, 3 in bracket 0.263 cube minus 4 in bracket 0.0.23 close bracket plus 1 over 9 in bracket 0.263 square minus 4. 0.264 is my answer. This is now very accurate. Guys, tell the truth. This is a very easy exam. Very easy exam, right? You don't even They're not asking you anything strange this year. Now, determine the Taylor series expansion of 1 over 1 minus 2x about the point. This look like x equal 3, including up to the x squared term. I think this is x cubed. Just to be safe, I'll write x cubed. I think it's x cubed. Right, so just to remember the formula for Taylor series, f of x is f of a plus f prime of a times x minus a plus f double prime of a times x minus a square over 2 plus f triple prime of a times x minus a cube over 6. So let's go ahead now and find like the derivatives. So f of x equal 1 minus 2x to the negative 1. So that means that f of 3 would be 1 minus 2 times 3 to the negative 1. I'll punch that in the calculator. 1 over 1 minus 2 times 3. Get minus 1 over 5. Then we need f prime of x, carry down the power, subtract 1 from the power, so multiply by the derivative inside the bracket. In other words, this is equal to 2 in bracket 1 minus 2x to the negative 2. So that means f prime of 3 is equal to, let's put that in the calculator, is now over 1 minus 2 times 3. And then this in the denominator is squared. So we get 2 over 25. Now f double prime of x is equal to carry down the power minus 4, subtract 1 from the power, but then multiply by the derivative inside the bracket. Carry down the power, subtract 1 times derivative inside, that's good. It is equal to 8 in bracket 1 minus 2x to the negative 3. So double prime of 3 equal, change this to, the numerator need to be 8. Change this in the denominator to be cube. And we'll get minus 8 over 125. So far, this paper is shockingly easy. F triple prime of x equal, carry down the power, subtract 1 from the power, multiply by the derivative inside the bracket. That works out to be 48 over the 1 minus 2x to the 4th power. And then we plug in, so f triple prime of 3 equal, let's plug that in. Change it to 48. Change this to the 4th power. That's 48 over 625. So now we can write an expression. So therefore, f of x, which is f of a was negative 1 over 5, plus f prime of a, so 2 over 25 times x minus 3, plus f double prime minus 8 over 125 times x minus 3 square over 2. And then we have plus f triple prime 48 over 625 in bracket x minus 3 cube over 6. So our final answer is f of x equal negative 1 over 5 plus 2 over 25 bracket x minus 3. 2 into itself 1 time, 2 into 8 4 times, so minus 4 over 125 x minus 3 squared. 6 into itself 1 time, 6 into 48 goes 8 times, so that's 8 over 625 in bracket x minus 3 cube. Okay, so that is f of x. No problem. This is f of x that we have right here. That's 9 marks. Easy, easy, easy. Come on, guys. This is easy. Now obtain. That's it. 9 marks for that. Obtain now the binomial expansion of this up to and including the x squared term. All right. So first thing is we notice that to do binomial expansion, you need it in the form 1 plus nx. So I have to factor out 16. So I have to say 16 minus 5x to the quarter is equal to 16 in bracket 1 minus 5 over 16 x. All of this is being raised to the quarter. This works out to be 16 to the quarter times 1 minus 5 over 16 x to the quarter. But 16 to the quarter is 2. 1 minus 5 over 16x to the quarter. Is 16 to the quarter 2? I'm just going to verify. I'm watching cricket and I don't eat breakfast, so not as focused. So I'll just punch this in. Yeah, it's 2. So now we can find the binomial expansion of this right here. So now 1 minus 5 over 16x to the quarter is equal to 1 plus nx, n times x, which is negative 5 over 16x, plus n times n minus 1, so quarter minus 1, x squared over 2. That would give us the series expansion. Because it's up to the x squared term. So time for my calculator. 1 over 4 times 5 over 16. That's minus 5 over 64. So 1 minus 5 over 16x to the quarter is equal to 1 plus minus 5 over 64x. And then now the next part is to work out that thing there. Quarter bracket, quarter minus 1, close the bracket. In this bracket, minus 5 over 16, close this bracket. And then I know that I'm going to have to square it. Then I have to divide it by 2. So that's minus 75 over 8,196. Minus 75 over 8,196. And then, of course, now, remember you have to multiply your final answer times 2. So if we multiply it by 2, we can say therefore 16 minus 5x to the quarter, which is 2 times 1 minus 5 over 16x to the quarter, is therefore equal to 2 times 1 minus 5 over 64x minus 75 over 8196x squared. Multiply each term by 2. So it's 92. All right, so that's what we have. Times it by 2, this is 2 minus. This is embarrassing to put in calculator. 2 times 5 over 64. 5 over 32, that's not bad. 5 over 32x. Then 75 over 8,192. Multiply it by 2. 75 over 4,096 x squared. That's your answer. Hence, meaning you're going to use this to do something. You know that's coming. Hence, oh, state the values of x for which your expansion is valid. Always remember the expansion is valid when whatever is there, x is between 1 and -1. So it's valid when 5 over 16, x is between 1 and -1. So if we multiply through by 16, it's valid when 5x is between 16 and -16. So it's valid when x is between 16 over 5 and -65. So it's valid, in other words, when x is between negative 16 over 5 is 3.2 and positive 3.2. That's when the expansion is valid. Easy stuff. That's so easy, guys. Come on, nobody can complain. That's too easy. Now use the expansion obtained in what you have earlier to find an estimate when x equals 3. So the actual answer you're supposed to get is 16 minus 5 times 3 to the quarter. That would be 1 to the quarter, which is 1. So we're looking to get 1 for our answer using the expansion earlier. So using our expansion, it is now 2 minus 5 over 32 times 3 squared. Put x as 3. Then minus 75 over 4,096 times 3 squared. So just plug in x where we had. All right, let me not skip any lines. Somebody might wonder, what am I doing? Remember earlier we said that 16 minus 5x to the quarter is equal to 2 minus 5 over 32. My gosh, he's batting. Minus 75 over 4,096. 3 now, right? So it's the expansion. This was the expansion you got. 2 minus 5 over 32 minus blah, blah, blah. And now we're going to evaluate this by plugging it in. So now we plug it in. 2 minus, we should get somewhere close to 1. 5 over 32 times 3. Had a bit of a connection issue, but continuing. Had a bit of a connectivity issue, but we should be fine now. And we were saying we're going to plug in 3 right here. Guys, notice in an hour, we've been working for an hour. We started 11:04. We've been working for an hour and we finished 3 questions. So if you're on your P's and Q's, right, you should be fine. So from this, we're getting 1.37 as our answer. We've done 3 questions in a jiffy. You've done 3 questions in an hour and you have 2.5 hours. So you have enough time, because I would say, because I'm a teacher, I can take 15 minutes faster to complete it. So if I finish this paper in 2 hours, you can in 2.5 hours, right? Being very fair. Now, use the intermediate value theorem to prove it has a root right here. Now, why is approximation in 3 and 4? So that don't make any sense to me. So first put in f of 0.2, 2 times 0.2 cubed plus 0.2 squared plus 9 times 0.2 minus 5 equal, I'll plug that in, 2 times 0.2 cube plus 0.2 square plus 9 times 0.2 minus 5 minus 3.144. And then now f of 1 is going to be 2 times 1 cube plus 1 square plus 9 times 1 minus 5. That's 3. 3 plus 9 is 12. 12 minus 5 is 7. So that's less than 0. This is greater than 0. So if I were to sketch a graph, I like to do it with a sketching a graph. If I were to sketch a graph, right, when x is like right here, 0 0.2, 0 0.4, 0 0.6, 0 0.81. When x is 0 0.2, the y value is somewhere right here, negative 3.14. And then when x is 1, the y value is 7, somewhere up here. This is 3.146.28. Somewhere right here is, so if I draw like a smooth curve, based on my graph, my root gonna be somewhere between 0 0.4, 0 0.6, somewhere about 0 0.7 is the root, right? Just based on my sketch. So by IMVT, there exists a root on the interval 0 0.2 to 1. That's it. I will show that 1 is less than 0 and 1 is greater than 0. Now it says use 3 iterations of interval bisection to estimate the root. So the first bisection, 0 0.2 plus 1 over 2 equal 0 0.6. So now we need to evaluate f of 0 0.6. Evaluating f of 0 0.6, you put 0 0.6 in the original cubic function. Right? So if we put 0 0.6 in the original cubic function, we have change 0 0.2 to 0 0.6, change 0 0.2 to 0 0.6, change 0 0.2 to 0 0.6. So that's giving us 1.192, 1.192, which is greater than 0. So that means the root lies on 0 0.2 and 0 0.6. So my answer wrong already. I was estimating 0 0.7, so my estimate is 4. So the root lies on 0 0.2 and 0 0.6. So now the second bisection, 0 0.2 plus 0 0.6 divided by 2. 0 0.8 over 2 is 0 0.4. So now we need to work out f of 0 0.4. The change is to 0 0.4. 0 0.4, 0 0.4, 0 0.4. That gives me negative 1.11. Negative 1.11, which is less than 0. That means the root lies on 0 0.4 and 0 0.6. So number 3, root lies on 0 0.4 and 0 0.6. So the bisection of that, 0 0.4 plus 0 0.6 divided by 2 is 0 0.5. So we'll finish right there because it says just use 3 iterations. All right, so the estimated root is 0 0.5 on that interval. Finish. So the estimated root is 0 0.5. Now what I'm gonna do, guys, I always ask that you do this. It's a cubic equation. Put it in your calculator. Take out your calculator. We're getting 0 0.5. Go on mode. Go on equation. Go on cubic. A is 2, B is 1, is 9, E is -5. Half, look at that. See there, the exact answer is half. And we got half as well. So we know we're correct. So the estimated root is half and the answer is half. So you finish, you're done. All right. So right here now, they ask us to find the first 5 terms. My back is hurting. Find the first 5 terms of this sequence. Whoa, what is going on here? All right, I see that the alternating plus between plus and minus. So I'm going to ignore that for now. I'm going to rewrite this because this is what, 4 over 1, -7 over 2, 10 over 6, minus 13 over 24. So I catch a pattern in the denominator already. In the denominator, notice that you're going up by factorials. This is 1 factorial, 2 factorial, 6 factorial. All right, so in the denominator is n factorial right there. Now in the numerator, if I add 3 each time, that is what? 3, that's 3 plus, let me see. Arithmetic progression is a plus n minus 1 times d, right? That's an arithmetic progression. So 3 plus what give me? That's 3n plus 1. So 3n plus 1 in the numerator. 3 times 1 is 3 plus 1 is 4. 3 times 2 is 6. 6 plus 1 is 7. However, I need to multiply it by some negative stuff because I want it to alternate between plus and minus. So I'm going to multiply this by, let's say, -1 to the n. If I put -1 to the n, when n is 1, I will get -1. So let me put n plus 1 right there. I'll put n plus 1 right here. When I put n as 1, 1 plus 1 is 2, positive. When I put n as 2, 2 plus 1, negative. When I put n, yes. This is it. That is not bad. But if I'm being honest, this seems like it would have been tricky. This might be tricky for students, but you can let me know, is this tricky? So the nth term is this right here. So let me call the nth term Tn, 3n plus 1 times -1 to the n plus 1 over n factorial. Determine whether or not the sequence converges. Whoa. Well, looking at it, let me see. 10 over, yeah, it's clearly getting smaller and smaller. It converges, obviously. Determine whether it converges. Yes, it converges, obviously. It can even... Well, I haven't seen convergence tests on the exam in a long while, but I'm still going to use convergence tests. All right, to do convergence test, all you need to do is evaluate this limit. All right, so sorry about that. So now what I'm going to do is evaluate the limit as n approach infinity of 3n plus 1 minus 1 to the n plus 1 over n factorial. Right, so just put in n as a very big number. Right, and if this last term is converging, then if the nth term is converging, then it does converge. So put in a number like, let's say, 1,000 times -1 raised to the 1,001 over 1,000 factorial. Well, the calculator can't go that far. Let me put 100, 100, 100. Can't go so far either. That's crazy. 50, 51, 50. Yeah, it converges. This is very small. So in this case, it's very small, right? So therefore it converges. Or what you can do also is if you know the convergence test, you can find Tn plus 1 over Tn, which would be 3n plus 1 times minus 1 to the n plus 2 over n plus 1 factorial divided by Tn. So that would become dividing by something is the same as multiplying by the reciprocal. 3n plus 1 minus 1 to the n plus 1. Then we notice that when doing this division, right, we notice that this would become, so this is a or. We know it converges, right? We already state whether it say yes. We state that the sequence converges, but this is another way to do it, another convergence test, right? So now minus 1 to the n plus 1 over, it's embarrassing I'm showing this working, minus 1 to the n plus 1 to the n plus 2 over minus 1 to the n plus 1 by the laws of indices, that's minus 1 the n plus 1 times minus 1 over minus 1 to the n plus 1, so that part would cancel. It's embarrassing to show that, so this would be negative 1. The other part where you have the n factorial over n plus 1 factorial. N plus 1 factorial is really n plus 1 times n factorial, and the n factorials would cancel. So far, Tn plus 1 over Tn would work out to be, this now, this cancel out that cancel out that. Then we have the 3n plus 3 plus 3n plus 4. So the numerator we have 3n plus 4. This part works out to be negative 1 over n factorial over n plus 1 factorial is now just n plus 1 in the denominator times our 3n plus 1. And then now evaluating this limit, 3n plus 4, then we evaluate the limit of negative 3n plus 4 over, this times this would be 6n squared. That's 3n squared, sorry. And then this time this is 3n plus, that's n plus 3n, that's plus 4n plus 1. Using L'Hopital's rule, right, differentiated. So it's roughly the same as evaluating the limit as n approach infinity of negative 3 over 2n plus 4. Plug in infinity, and you get plug in infinity, you get minus 3 over infinity, 0. So yes, it converges. Right, it converges. It does converges. So we can state it converges. Yeah, man, so it does converge. Nice. These are very ridiculous question. Calculate the sum from 11 to 27 of. You literally can just add 11 plus 12 plus 13 plus 14 plus 15 plus 16 plus 17 plus 18 plus 19 plus 20 plus 21 plus 22 plus 23 plus 24 plus 25 plus 26 plus 27 equal. Now add up that. That's very easy. That's surprisingly, guys, you cannot say this paper was hard. 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. 323 is your answer. Another way to do it is, if you want to say maybe another way to do it, or you can say the sum from 1 to 10 of R plus the sum from 11 to 27 of R is equal to the sum from 1 to 27 of R. So that implies that the sum from R equal 1, or the sum from 11 to 27 of R is equal to the sum from 1 to 27 of R minus the sum from 1 to 10 of R. So it's equal to, using the formula, half n in bracket n plus 1. So it's half (27) in bracket 27 plus 1 minus half in bracket 10 in bracket 10 in your calculator, right? Half in bracket 27 times 27. I'll punch that in the calculator. I'll get the same 323. So it depends on how you want to do it. And do it either method 1 or method 2. Or, nah, that way gonna take too long. That way gonna take too long. But yeah, you can use a calculator and verify the answer is right. I thought that was ridiculously easy. This is unit 2, not unit 1. So far, I haven't heard much comment on the paper, but so far the general gist is it wasn't a bad paper. I would believe so. It wasn't a bad paper. Right here, use the sum of a series to calculate an equivalent fraction for repeating decimal. Usually question 4 is about approximation. So why is there so much sequence and series? So use the sum of a series. No problem. So what we know is that 0.27 would be equivalent to 27 over 100, right? And then something like 0.0027 is equivalent to 27 over, that's like 1, 2, 3, 4, 0, 3, 2, 3, 4, 0. Look what I'm doing, guys. I did the first 2 zeros, then I did the first 2 decimal places and the next 2, and now I need 0 point, and the next one would be going up to here now, going up to here. I'm just doing it by every 2. Then I have 0.000027. That's 27 over 1, 2, 3, 4, 5, 6 zeros. Right? And it continues. So this, what am I saying, guys? I am saying 0.27272727 is the same as if you were to add 0.27 plus 0.0027 plus 0.000. R is 0. Having some internet issues today, so it might be bugging a little bit, but hopefully that's the end of it. Nicholas Puran is out. Oh man, Nicholas Puran is out. All right, now continuing with phone R. Remember this right here then, the 2727 continues forever, so it's sum to infinity. And sum to infinity is A over 1 minus R. So your first term is 0.27 over 1 minus 1 over 100. And then we'll put that in the calculator. 0.27 over 1 minus 1 over 100 equal 3 over 11. So that would be a recurring decimal right there. So that means if you put in a calculator, 3 over 11, so you get the 0.27272727272727 forever and ever and ever. So guys, that was easy. That was ridiculously easy. So module 1 and module 2 wasn't bad. Now we know module 3 can be detrimental, but let's see. Given that the matrix is singular, calculate the values of P. So a singular matrix means the determinant equals 0. So that means 1 minus P times the determinant of cross the row and column with 1 minus P. I have P minus 1, 2, 1. Then minus 3 times the determinant of cross the row and column with 3 in it. You have 2 minus 1 minus 3, 1. Then you have minus 2 times cross the row and the column. You have 2p minus 3 and 2 equals 0. This works out to be 1 minus p times, this is now p plus 2 minus 3 in bracket. That's 2 minus 3. Then minus 2 in bracket, or plus 3p equals 0. That looks like it leading to a quadratic. So it leads to a quadratic where we have 1 times p is p. Then we have plus 2p. Then we have minus p squared. Wait, let me go again. 1 times p is p. 1 times 2 is 2 by itself. Then p times p squared. P times 2, that's minus 2p. Then here now 2 minus 3 is negative 1. Negative 1 times negative 3 is positive 3. Then minus 8. 2 times 4 is 8. And 2 times 3 is 6. So minus 6p equals 0. Simplifying, we have minus p squared. P might, oh, can't take the whole heap of negatives, guys. 1p minus 2p minus 6p. That's minus 7p. Then checking with the numbers, we notice we have 2 plus 3 minus 8. That's 2 plus 3 minus 8. That's negative 3 equals 0. That multiply through, that's p squared plus 7p plus 3 equals 0. I doubt this is right because they tend to not give you weird values for p. I'm just going to check it over again. Cross the row and the column, that's p minus 1, 2, 1. That should be p plus 2. Yeah. Cross the row and the column with 3 in it, that's 2 minus 1, that's now 2. And that's now minus, that's minus 3. That's 2 minus 3 times negative 3. Then minus 2 times cross the row and the column, that's 2p minus 3, 2. That's 4. 4 minus minus 3p is plus 3p. This is minus 8 minus 6p. I put in my calculator, minus 3 bracket, minus 3. That's positive 3 here. Then over here now, this is now p plus 2 minus p squared minus 2p. 1 minus 2 is negative 1, negative 1. Okay, so this seems fine. Quadratic seems fine. So now p would be equal to, I'm using my quadratic formula, 1, 7, 3. So I'm getting p equal minus 7 plus root 37 over 2 or minus 7 minus root 37 over 2. Now, this is why I love this calculator, guys. I don't trust when I get answers like this. So I just go to matrix. So 3 by 3. I'm going to put A as P right there. Because this, I don't think this is going to be 0. So let me just check something. Minus 7 plus root 37 divided by 2. This is negative 0.4586. Negative 0.4586. Now I can go to matrix. So I have 1.4586 there, I have 3 there, I have negative 2 here, I have 2 here, I have my answer there, I have negative 1 here, I have negative 3 here, I have 2 here, and I have 1 here. I'm supposed to get my determinant being 0. Then I know that that value for P is correct. So now I'm going to evaluate my determinant of matrix A. Come on, please be 0. Yes, it's 0. Come on, Barminas. So we're right, guys. These are the two values for P. It's just that that's very weird. Oh no, that we get them weird values there for P. No problem. I absolutely cannot see this, and this is, I can't see this page. Oh, this is better. All right, so let's write it over so you can see 3x minus 4y plus z equals 16, 2x plus y minus 2z equals 5, x plus 2y minus z equals negative 2. So using row reduction, 3 minus 4, 1, 2, 1 minus 2, 1, 2 minus 1, augment 16, 5 minus 2. So what I'm going to do is I'm going to interchange row 1 and row 3. So I'm going to turn it into 1, 2 minus 1, augment minus 2. Then I have 2, 1 minus 2, 5. Then I have 3 minus 4, 1. So now what we're going to do is we're going to say, okay, we're going to change row 2, and we're going to let row 2 become, we're going to change row 2 to 2 row 1 minus row 2. I'm going to change row 3, so row 3 is going to become 3 row 1 minus row 3. So our new matrix is, put back row 1 as it is, 1, 2 minus 1, augment negative 2. But then row 2 become 2 times 1, 2, 2 minus 2, 0. 2 times 2, 4, 4 minus 1 is 3. I don't like dealing with negatives, so I bring out the calculator. 2 times minus 1 minus 2, negative 4. And then 2 times, again, I don't like negative numbers. I really don't like negative numbers. So just to be safe again, it's 2 row 1 minus row 2. So 2 times minus 1 minus 2. It's actually 0. So I don't like negatives, guys. You have to be so careful. That should be actually be 0. You have to be so careful. Then right here now, did you say reduce the echelon form? Use row reduction to solve. I don't want to put this in echelon form. This is perfect, but you know what? I'll do what they want. So this is what we have, 0, 3, 0. And then now 2 times minus 2 minus 5. That's negative 9. And then now, row 3 is 3 times 3 minus 3 is 0. And then 3 times 2 is 6. 6 minus negative 4 is 10. And then now 3 times minus 1 is minus 3. Then you subtract 1, that's negative 4. And then 3 times minus 2 would be minus 6. And then you subtract 16. Let me just make sure I do that right. 3 times row 1 minus 16. Yeah, minus 22. They say you use row reduction, so naturally we already said that y should be minus 3, but just to continue, we need to get a 0. Well, you know what? I'm going to switch it again. I'm going to switch this to become 1, 2, minus 1, minus 2, 0, 10, minus 4, minus 22. Then I have 0, 3, 0, negative 9. Even though from this I clearly realize that y is minus 3, but I'm not going to use that. I'm going to say now, my row 3 is going to become 10 times row 3, and I subtract 3 times row 2. So put back row 1 as it is, put back row 2 as it is, 0 here, 0 there, and then now I go 10 times row 3, 10 times row 3, 0, minus 3 times row 2, which is minus 4, is 12, positive 12 here. So this part is 12. And now I'm dealing with these two numbers. So 10 row 3. So 10 times, man, this is so tiring. 10 times negative 9. I need to go eat my lunch. 10 times negative 9 minus 3 times minus 22 minus 24. Man, that's tiring. Minus 24. So from this, obviously, 12z equal minus 24. And so z equal minus 2. Once I get z equal minus 2, you're going to back substitute. So therefore, 10y minus 4 times minus 2 equal negative 22. Bring it over. This is now 10y plus 8. So when you carry it over, it's minus 22 minus 8. So 10y equal minus 30. Y equal minus 3. Once you get y equal minus 3, you back substitute again, because now you need to find x. So 1x plus 2y minus z equal negative 2. So that means x plus 2 times minus 3 plus z, which is negative 2 equal minus 2. Bring everything to one side. X equal minus 2. Minus and minus turn plus. When you carry that over, it stay minus. Then 2 times minus 3 is minus 6. When you carry it over, it becomes plus 6. That's minus 4 plus 6, which is positive 2. So your solution is x equal 2, y equal negative 3, and z equal negative 2. Those are your answers. Now, I always like when you test it, right? Check it. You need to do what? Check it. Check your answers in any equation. Let's check it in the second equation. 2 times x, which is 2, plus y, which is negative 3, plus z, negative 2. Punch it in the calculator. Whoa, guess what? We made a mistake. Do you see where we made a mistake? We have 2x plus y plus 2z should be 5, but I'm getting negative 3. Uh-oh. Let me check in the first equation. 3 times 2 minus 4 times y plus z it works in the first equation. So that means where would I have made a mistake? Let's try it in the third equation. 2 plus. So guys, I'm glad that I'm doing this. Working through, you're watching the time. I wanted to see if I finish in the 2 hours as promised. 2 times y minus z. I should get -2. I get -2. Checking the second equation again. 2 times 2 plus y, which is -3, minus 2 times z. Oh, no, everything is fine. Come on. Everything is right. Well, guys, I'm doing this kind of live. Even though I'm not actually live, you can actually watch my time. We started 11:04, right? And you can actually see I'm doing this along the way. Not taking any breaks or going anywhere. In my one shirt, no breaks, no nothing. I'm gonna work it. Now it says a committee consisting of 3 men. So the committee must have 3 men on it. And it's to be formed from a group of 6 men and 4 women. However, it is known in advance, 2 men who dislike each other will not serve together on the committee. You know how many different ways can the committee be formed? So 2 men who dislike each other will not serve together. That's the key. Okay, so we get the scenario. So I like to break it up in cases. So case 1, so we have 6 guys, right? I'm gonna write it as Foreman, Bob, and Brian. So Bob and Brian don't like each other. This is how I process things, right? You don't have to do it the same way. So case 1 is neither Brian or Bob selected. That's case 1. Because they don't like each other, but we don't select none of them. So we choose from the 4 guys. From these 4 guys, we choose how many men we need? 3. So we choose 3 guys from those 4. Let me write it like this. We choose 3 guys from those 4. We don't choose any of Brian or Bob. And then we choose how many women? 2 women from 4. So 2 women from 4. That's case 1 where we choose neither Brian nor Bob. And then we'll put this in the calculator. 4 choose 3 times 2 choose 0 times 4 choose. There are 24 ways this can be done. 24 ways. That's case 1. Case 2 now, let's say Brian, but not Bob, because Brian don't like Bob. That's just how I process it, right? Brian, but not Bob. So if we choose Brian, we choose Brian. So we choose Brian, we choose one of the 2, but not Bob, times. That means if we choose one of Brian, only 2 other guys can be chosen from the other 4. They will just choose 2 women from 4. I'm going to put this in the calculator all in one time. So 2 choose 1 times 4 choose 2 times 4 choose 2. 72 ways. Then case 3 now is Bob, but not Brian. We have to ensure that the 2 of them, they're not serving together. So we choose Bob, but not Brian. You know what? Let me 2 choose 1. I need to write this as 1 right here. Let me see something. Because we said that we're choosing, right? We choose Brian. We know we choose Brian. We definitely choose Brian, but we don't choose Bob. So there's only one way of choosing Brian. So we choose Brian, but not Bob. That should be 36 here. Should be 36. You know what? I'm not going to write it as case 3. I'm going to write it as 2 cases. I hope you understand what I'm saying. This is 76 ways. And this is the, just going to rephrase my case. Rephrase my case as choosing Brian or Bob, but never both of them. These are 76 or 72. Got to put it back in the calculator. So what I do is I choose any one out of the two of them. It's either I choose Brian or I choose Bob, right? And I think that was, oh no, it was 72. This was 72. Then I add them. So the total is equal to 72 plus 24, which is equal to 96 ways. No, that's that, 96 ways. That's 7 marks. We'll take it. We'll take it. I still don't know why that is 7 marks. I don't know. I don't know. Now, this is, I don't like how that picture look. What is the probability that the committee will contain neither the two of the men who refuse to serve together? So the probability of neither, we worked out neither any of them was 24 ways. That's 24 over the total ways the committee can be selected, which is 96, which is a quarter, which is 25%. That's it. 3 marks there. Done. On to question number 6, the last question. Man, a chemical test kit is 95% accurate in detecting when a solution is acidic. However, the test kit is also yielding a false positive result for 1% of all solutions tested. If 0.5 of the solution tests are acidic, what's the probability that the solution is acidic given that the test result is positive? All right, so let me start from scratch. When you test some solutions, it's either going to be acidic or non-acidic. Okay. So this is either acidic or non-acidic. So I'm going non-acidic, I'm going to put acid prime. And they said that 0.5, the solution are acidic. So 0.5%. Whoa, that's crazy. 0.5%. So 0.5% are acidic. So I divide 0.5 by 100. Is to get it as the decimal. This is 1 over 200. So being acidic is 1 over 200. Being non-acidic is 199 over 200. Now, afterwards, I said that it can either have a false positive. So this is either false positive or it's going to be a true positive if that is such the term. Is 95% acidic. So right here is what, 95%? 95% when it is acidic, 95, so this is 5%. And then now, the kit also is a false positive for 1% of all solutions tested when it's false positive. So this is what, 1%, let's say. 1%. This is 0.99. Okay, now what's the probability a solution is acidic given that the test result is positive? So what's the probability the solution is acidic given that the test result is positive? All right, so in that case, this is conditional probability. So it's acidic and positive over probability of being positive. Acidic and positive is 1 over 200 times 0.95 over being positive is now 1 over 200 times 0.95 plus 1 over 199 over 200 times 0.99. I know you're probably wondering, why did I mix up fractions and decimal together? I really don't know. I don't know. But 1 over 200 times 0.95 over 1 over 200 times 0.95 plus 199 over 200 times 0.99. Oh, that's crazy. That's 0.0048. So this is, what's the probability that the solution is acidic? Is 0.004, 0.00448, which is roughly 0.48% chance. All right, that's that. Now I have a first order differential equation. First thing is you find an integrating factor k, which is e. Find an integrating factor I mean, which is e to the integral of k dx. It's e to the integral of 3 over x dx, which is e to the integral of 3 times 1 over x dx. Integral of 1 over x is ln x, so that's 3 ln x. So this is e ln x cubed, e and ln cancel, so that's x cubed. So your solution is y times the integrating factor equal the integral of f of x, which is sine 2x over x cubed, times your integrating factor times x cubed. So we end up get y times x cubed equal x cubed over x cubed cancel. You just have the integral of sine 2x dx. Integrate sine 2x, you get, integrate sine, you get negative cos. You divide by 2 plus some constant c. So then you divide through by x cubed. So your final answer, y is equal to minus cos 2x over 2x cubed plus c x cubed, which can be written as, c over x cubed. This is your answer. That's very easy for 5 marks, no problem. All right, a differential equation is given by this right here. So solve this differential equation. Show that the general solution is this. AE to the 3/4, blah, blah, blah. So first thing though, 4y double prime minus 6y prime plus 7y equals 0. Solve your auxiliary equation, 4m squared minus 6m plus 7 equals 0. So solving it, so from this, m equal minus b plus or minus, well, minus 6m is plus 6m. So it's minus b plus or minus the square root of b squared minus 4 times a times c over 2a, 2 times 4. So that means we'll have 6 plus or minus 6 squared is 36. We'll have square root 36 minus 4 times 4 times 7. Put that in the calculator. 4 times 4 times 7, which is 112 over 8. 36 minus 112 minus 76. So I have root 76i. So m equals 6 plus or minus root 76i over 8. 6 over 8 is 3/4. Plus or minus, put root 76 over 8 in the calculator. You get root 19 over 4. So therefore, your general solution is y equal, therefore, y equal e to the 3 over 4x in bracket a sine root 19 over 4x plus b cos root 19 over 4x. How much marks this? We take that. We take it. That is easy. We take it. We take it. We take it. We take it. That is nice. You take that. Come on. That is nice. That is very nice. So yeah, we did that. We prove it. Only difference now is they expanded it to say that their answer is y equal ae to the 3 over 4 sine root 19 over 4x plus be to the 3 over 4x cos root 19 over 4x. So they expand the bracket. We didn't expand it right here. That's fine. So we got those 6 marks. That's no problem. Now they say hence or otherwise determine the particular solution when x is 0, y is 3. So when x equals 0, they told us y equals 3. So we're going to sub it in here. This is our solution for y. So y is 3, so we have 3 equal e to the 0. So e to the 0 is 1, so I can just put 1 times sine 19 over 4 times 0. I can just put 0 plus e to anything is 1, then cos 19 over 4 times 0. But sine 0 is 0, so 3 equal 0 plus, now cos 0 is 1. So that means b equals 3. Now once we get b equals 3, remember y is ae to the 3 over 4x sine root 19 over 4x plus b, so that's now 3e to the 3 over 4x cos root 19 over 4x. So all we have to do now is differentiate and plug in. They said the derivative is 0, so at the stationary point where dy by dx is 0. So we differentiate dy by dx equal, we're going to have to use product rule. Keep the first, times the derivative of the second. So cos root 19 over 4x multiplied by the derivative. So when you differentiate sine, you get cos. When you differentiate sine, you get cos, and then now multiply by the derivative inside of the bracket. Right? So now we'll multiply by the derivative inside the bracket. Well, I think I hear a knock. Give me a second. All right, sorry about that, but we'll multiply now by the derivative inside of the bracket. Multiply by the derivative inside of the bracket, which is root 19 over 4. Plus, keep the second, the sine root 19 over 4x. Keep the second, multiplied by the derivative of the first, and the derivative of the first, that is differentiate 3/4 x is just 3/4. I'm going to write 3/4 as 3a over 4 e to the 3/4 x. Right? So that's that part. Keep the first, differentiate the second, plus keep the second, differentiate the first. We're going to have to do the same thing for over here now. So plus keep the first 3e to the 3/4 x, then multiply by the derivative of the second. But when I differentiate cos, I get negative sign. So minus 19 over 4 sine root 19 over 4x plus keep the second, the cos root 19 over 4x. Then you multiply, of course, by the derivative of the first, and the derivative of 3/4 x is 3/4, and then we multiply the 3/4 times 3. I'm getting old. 3/4 times 3. 3/4 times 3 is 9 over 4. So this is now 9 over 4 ae to the 3/4 x. Now they told us the second derivative is 0. So that means that since dy dx is 0, you have 0 equal. When dy dx is 0, x is also 0. So right here, we can tell them when x equals 0, dy over dx equals 0. So that's why we'll put in 0 equal. E to the 0 is 1. So a in bracket e to the 0, 1 times the cos of 0, and the cos of 0 is 1 times root 19 over 4 plus sine 0 is just 0, so we can put 0 there. Sine 0 is 0, so we can put 0 there. And then the cos of 0 is 1, so we can have 9 over 4 a times 1 times 1. So which means that 0 equal, this is now root 19a over 4 plus this part right here is plus 9 over 4a. This is the same as 9 plus root 19 over 4 times a. It's equal to 0. Multiply through by 4. Multiply through by 4, so that means 2 times by 4. 0 equal 9 plus root 19a. Bring it over, which means a equal, this looks like minus 9 over root 19. And I don't think that is proper to leave as the answer. So we're going to rationalize it. 9 over root 19, which is 9 root 19 over 19. 9 root 19 over 19, put a negative. So now we can have our general solution. So therefore, the general solution is y equal a to minus 9 root 19 over 19 e to the 3/4 x sine root 19 over 4x plus b, which is 3 e to the 3/4 x cos root 19 over 4x. I will finish just like that. That's the paper there. So you realize it is not a bad paper, not a bad paper, right? It's not a bad paper at all. That's it. Sweet. All right. So that's it. Let me know about the paper. I thought this year was very easy, but do let me know. All right, do let me know. Only thing I would say now is remember paper one, deal with paper one, swat like crazy. Keep on swatting and you should be fine. Because pure math, not so bad when you look at it.